Hi guys, I was doing some work on sorting algorithms and came across the problem of sorting strings, and I wanted to share with you my findings. Well, as you know, there are two groups of sorting algorithms, comparison-based and non-comparison-based. You probably have heard about the comparison-based ones because they're more popular, like selection sort, bubble sort, quick sort, merge sort. But the other group, which is non-comparison based sorters, they are less known, maybe less popular. But among them, there are famous algorithms like counting sort, or bucket sort, or Radix. To begin with, I want to remind you what comparison-based sorter is and why it is called a comparison-based sorter. I took selection sort as the example. You can see the pseudocode on the left, and the array we want to sort it on the right. We start from the first position and then we move one by one to the right, one step at a time. We start from the first position, I is equal to 1. I try to find the smallest number from that point on in the list or in the array. In this case, it is the fifth one, which is number 1. I mean, the value is equal to 1. What I do is I swap the places of these two numbers. Okay, then I've got the smallest number in the first position. Then I move to the second position. I try to find any number that is the smallest from that point on. But there is none. This is the smallest number already. I mean, 2 is the smallest from that point on. So I leave it as is and I move forward to the next position. In the third position, I have 5, but there is a smaller number. The smallest one from that point on is 4, which is in the fifth position. So I swap the places of these two. And then I move to the fourth position. Again, I can find the fifth position smaller. I swap them. So at the end, after running this algorithm, you are left with a sorted list or array. If you take a closer look, we have two loops in this algorithm. One is the outer loop and the other one is inner. The outer loop runs from 1 to n. The inner loop runs from I, which is the value of the outer loop, to the ends, to n. But in terms of complexity, we say that the inner loop is of On, and the outer loop is, which runs from 1 to n, is definitely of On. So altogether, this sorting algorithm is of On squared. This is the Java code for the same algorithm. And if you take a closer look, inside the second loop, there is an if that does the comparison. And that's why it is called a comparison-based algorithm. Okay, but what do we do with the strings? If I can come up with a way of comparing strings and say which one is smaller and which one is bigger, I can use the same sorting algorithm. In this case, we have got two words and an ABC, and I want to know which one is bigger. So I start from the leftmost character, in this case A, but it's equal in both of them, so I can say which one is bigger. So I have to move forward and I move to the second character. For the second one, I have got N and B. If I follow the alphabets, N comes after B. So in this case, N is greater than B. And I can say, oh, okay, so N is bigger in general than ABC. Now that I have a comparator, a comparison algorithm, I can a comparison operator, I can run the same algorithm on the strings. But we don't have to implement the comparison operator by ourselves. And there are methods for them in every language. Like in C# we have got compare, and in Java we have got compare to. There is a difference in syntax because in Java strings are instances of a class. So I can say string A dot compared to string B, and it compares string A and with string B, and then returns either a positive, a negative, or zero value. Positive if it is greater, negative if it is smaller, and zero if they are equal. And finally, this is the Java code for sorting strings based on selection sort. And again, if you look at the inner loop, you can see the comparison operator. Okay. But we told you that there is another way of sorting stuffs, especially strings, and that is by using non-comparison based sorters. Well, non-comparison based sorters, they don't use comparators. They don't use comparison operator. They group stuffs and then combine them again and then group them again based on a different criterion this time. Like, let's take a look at Radix, for example. We have got 8 words here, mom, dad, fat, and so on. I start from the right hand side. I group them based on the last letter. Dad, bad, and mad, they fall into the same group because they all end with D. Mom and him, they also form another group because they end with M, and so on. I combine this group list again and I get a list. I can assume this is like the original list, but this time I group them based on the second letter. Just notice that 6 of the words, they go into the same group because they have got A in the middle, all of them, except 2 that form 2 isolated groups, and then I combine them again, and I do the same on the last letter, and the third one from the right, and I come up with this. When I exhaust all the positions for all the words, if I combine them in the last iteration, I get a sorted array or list. Just take a look. Bat comes before bar, definitely, because D comes before R. And bar comes before cat, and cat comes before dad. You can verify that's already sorted. But the interesting part is that this algorithm runs in O of n, which is much less than O of n squared compared to the selection sort we had. The reason is that it doesn't do comparisons, it just do grouping for every position. And because we don't have, and for every word and every position, because we don't have many letters, let's say it's a constant k at most, and we do for every word, so it's O of k multiplied by n, and k isn't counted in complexity analysis, so we say at the end it's O of n. What if the strings are of different size? We simply pad them to solve the problem. For example, we have got cat and boot have different sizes. I add a letter at the end with the least value. Let's say capital A has got the least value, and even lower letter A is more valuable, is greater than capital A. Then after doing this, I'm okay to run Radix algorithm. For the numbers, we pad them similarly if you want to use Radix algorithm, but this time from the left with the least valuable quantity or character, which is 0 in this case. So to wrap up, we said that there are 2 different kinds of sorting algorithms, comparison-based and non-comparison-based. Comparison operators can be defined for strings, and then we can use the classic sorters to sort the strings. Some non-comparison based sorters can directly work on strings, like Radix, as we saw. And the interesting thing is that the worst case order of complexity for comparison-based sorted doesn't go below n log n or O of n log n, but for non-comparison based ones, they can go as low as O of n. So that's it. And I hope that you've liked this, and thank you for watching.